All right, good morning. Let's get started. Hope you enjoyed the keynote. We have an exciting session next. First of all, my name is Ram Appalaraju. I'm the MC for this session. My primary business is I'm an executive analyst at Ring Strategies. We focus on AI and quantum computing in terms of technology and business strategies, advisory services. Today's topic is around the deep learning models for financial services from SK Reddy. He's the VP of Data and AI at Fidelity Investments, so he knows where all our money is. And it's a pretty impressive background what SK has. He's a Chief Product Officer at AI in Hexagon, and he's an AI expert and a successful twice startup entrepreneur. And he's very busy both on LinkedIn and YouTube. I highly encourage you to follow him up on those areas, right? What attracted me to his abstract is some wonderful terms that we all like to know about the risks and the regulatory aspects of pursuing AI models. They're not trivial by any means. It's not necessarily business's control. When you bring in a regulation, those tend to change over time, and staying ahead of them is a big challenge, and I'm very curious to hear about that. The second thing is about the predictive nature of the business. There are a lot of businesses where predictability is important. But here in the abstract, SK talks about predictability of recessions, right? That's a far-reaching topic, very timely for us. Needless to say, this is really the cutting edge of bringing in AI technologies into core of financial services. Let's welcome SK and have him present this to us. Thank you.
Thank you, guys. Thank you very much for coming. I'm going to be standing here and talking. I know the slides are there. I prefer to walk up and down there, but I do have a recording session going on, so I'll stay here. For the next 35 minutes, I'm going to talk about a bunch of use cases within the financial services industry. Of all the industries that's going through a tremendous transformation where AI is coming in, I personally believe financial services is making a tremendous use of AI. Both in terms of the complexity of use cases, the amount of data, the regulations. Also, at the end of the day, I think we're talking about using people's money, and you've got to be extremely careful about how to make more wealth for the customers. But at the same time, being from Silicon Valley, now in Boston, I'm going to talk about how easy it is to develop some of the financial services solutions. So if any one of you is trying to do a startup in financial services, I'm going to make it extremely easy to think about potential use cases and potential solutions too. That's point number one I would like to emphasize. And point number two is, if you look at all the technical papers being published in AI, whether it's image processing or NLP, there's a tremendous amount of deep learning models being proposed. Even though I'm going to talk about a couple of deep learning models in financial services, I will talk about some solutions where people have published papers on using simple and classical machine learning techniques. Some of the most commonly used techniques for classifications, clustering, I'm going to be talking about those papers. As I'm not allowed to talk about what we're doing in my company, I'm going to talk about some research that's happened in published papers to showcase the simplicity of these models. But my main point in the next 30 minutes or so would be to talk about not just the implementation of these use cases, but the need to have more of interpretability and explainability into the models. You might have heard of the GDPR coming to force a few months ago, but going forward, I'm expecting a lot more countries coming out with more legislations where it's expected of to actually explain why certain decisions were taken by the model or otherwise. Credit scores, I remember 30 years ago, even actually I go to the next slide, Fair and Isaac company, FICO scores, was invented I think of 30, 40 years ago, and there were only a few techniques being used to identify the credit scores of people. But things have changed now. I think there's a lot of alternative data being used to predict creditworthiness. There are so many papers published where you can identify more bankable customers who are otherwise not easy to find using your traditional credit scoring mechanisms. And AI, a lot of machine learning techniques are being used. And if you look at this paper, by the way, at the bottom of every slide, I do have a link for you to further go do research on that particular information. There are companies using alternative data to identify creditworthiness. I was talking to Alan Dell, I think is the name of the guy, who is a brother of Michael Dell. He founded a company, I think a couple of years ago, and recently Goldman Sachs acquired the company. 30 or 40 people company, ran for 2 years. I want you to go do the research on how much they were acquired for, at least $3-digit $1 million numbers. They were trying to identify potential customers who they could loan money who have credit card problems. So now translating a credit card problem into a loan problem and customizing the loan terms for each and every consumer. If you're a blue-collar worker and you cannot pay on a monthly basis, the loan would customize your monthly payments. If you want to pay more sometimes, you want to pay less sometimes, the loan is automatically adjusted for you. They had 100,000 customers at the time of acquisition. They had 100,000 loan models available, and they had 100,000 credit score prediction models available. They could just predict what's the creditworthiness of a person. Here is one interesting paper. You think about, to predict the credit of a person, you need to have maybe 1,000 features, 500 features, or 10,000 features. This is a paper which I want you to go, guys, read. Just the 25 features or 30 features. Using 30 features, it's called a thin file of a customer. You can make an accurate prediction of creditworthiness of people. So whether you're buying a car or buying a home or applying for a loan, any type of scoring can be done with simpler data. If companies are helping you to make more money in your stock market transactions, like a portfolio management, how would you identify what's the right mix of stocks? Literally, the combination of stocks, including mutual funds and so many other units, you can have millions of combinations based on your risk appetite. Here is one paper which uses classical machine learning technique, multi-armed bandit method, to identify best yielding portfolio for you. So if you don't want to go to an advisor, financial service advisor, and want to identify the best portfolio that's suitable for your credit risk, check out this paper. I don't know whether they actually open source the code. This paper was published a couple of years ago. You would be able to find out the best combination of portfolio, what you're looking for. Very simple technique. Similar is the case if you want to identify the best combination of portfolio in some sort of indexing. If you want to find out what combination of stocks would give the results what you're looking for. There's another paper I think published again a couple of years ago. You want to find out. The most common use case in any financial services AI company is fraud detection. Of course, that can be applied for any type of fraud. It doesn't have to be a credit card, but it could be a warranty fraud. It could be any type of fraud detection or any type of anomaly detection, anything which is unusual. You don't want to lose money. In a credit card transaction, you actually have a couple of simple techniques companies use right at the card transaction event, like just the basic PIN and the swiping, and those techniques could be used to prevent fraud. And then in the next stage, maybe you can also have a bunch of business rules. If you have the same customer using the same card at the same location for n number of times in a very, very short time period, could be a violation of certain policy, and then you can detect a fraud right there. But if these instantaneous techniques are not still sufficient to detect fraud, you can do some AI machine learning technique too. For example, here is a paper, amazingly simple solution, and they compare and contrasted 7 to 8 different classical machine learning techniques, which are a bunch of clustering techniques and a bunch of classification techniques. You have expectations management, k-means, farthest first, x-means, density-based models in just the basic clustering techniques, and the classification could be the usual suspects were used. But what's the most interesting point in any credit card transaction is the data. You will never get a balanced data. The number of good transactions versus the number of bad transactions is always imbalanced. And here is a paper which actually talks about how do you develop a model when you have such a imbalanced data. Well, there are a bunch of techniques many companies use in terms of trying to do the data augmentation. You actually can create data, synthetic data, but here they use just the data, the imbalanced data, 99% versus 1% of fraud data. And the interesting part of this paper is the accuracy rates and the other metrics, the precision recall rates, are very, very high for even some of the most simple classical techniques, whatever mentioned here. So if you guys are developing, if you work for a company or if you're doing your own company, and if you're developing some simple anomaly detection, any type of fraud detection, this paper would be an interesting solution for you. Now here's the one I think Ram was talking about, recessions. Forecasting is predicting what's going to happen in future. Predicting recession sometime in the future is of no use for us. This is the only one use case I would imagine where you want to predict now. It's now casting. You got to find out, are we in recession? Just to give a little bit of a historical perspective on recessions, people would not know that you're in recession till it's already 3 months late, sometimes even 6 months late. But it's very, very difficult, especially in the first 1 or 2 months. I think it's so difficult to know if you're in recession. It's always in the hindsight you would know you're in recession. And of course, it's too late in sometimes, especially if it's a difficult business you are in, you can't take corrective actions at a late stage. And here is an interesting thing, even though this paper, I think, talks about predicting now casting recessions, they only had 6 recessions which actually happened in the over period of in the last 15 years to develop a model on. So I don't know if you have ever encountered a AI use case where the number of data points you used is not in millions, not in hundreds of thousands, not even in thousands, not even in hundreds. There are only 6 data points they used a model to detect, and they used 4 for developing model and 2 for testing. It's very interesting, and I've read the paper. I've not used the code. I don't know the authors. Actually published just a couple of months ago. It's March of 2019. It's very interesting. Of course, predicting recession, maybe I think the need for big companies, I don't know whether it's used for you guys or not, but this paper throws a unique light on how to develop a model when you have very, very small data set. And this actual paper predicted with very high accuracy, but then we can get into the debate of if you have only 2 data points for testing purposes, how good is the model? We don't know. But it's an interesting take, and I really wanted to bring it to you guys, because you normally don't find such a paper where you're talking about such an important critical aspect in the business side, and you don't have enough data points. And also, I guess they would have taken recession data points maybe 100 years ago, 200 years ago, but it's of no use because things have changed so much. One of the biggest problem in the financial service industry, if you are from that industry, you would know things are constantly changing. It's not just the stock market activities that are influencing stock market, but there's so many external factors which are influencing the stock market, and that's what is an issue. So nowcasting recession is an interesting paper. You should check it out about what it is. And one of the dream for every individual who's investing money in stock is to what? Is to predict what's going to happen to the stock next day. Yeah, you want to know what's going to happen tomorrow so that you can buy or sell. And there are a lot of solutions being proposed. I remember a couple of years ago when I was talking to a gentleman who was trying to hire interns to do some experiments and projects. And the win-win for the students would be to learn AI, but win-win for this gentleman was to have free AI models developed by these young engineers. But what they were doing was they were actually developing models to predict the stock market scenario, especially for hedge funds. You will be surprised, even though the entire financial services industry is in the East Coast, there are lots of companies in Silicon Valley, and especially in San Francisco, which are working for those small hedge funds, running, let's say, a couple of $1 billion to predict what's going to happen for company ABC stock or maybe a couple of mutual funds. They were doing a bunch of techniques. And at that time, this is 2 years ago, where Deep learning models were still just coming up in financial services, so they were using a lot of classical machine learning. Here is one deep learning model where I think people were predicting what will be the stock direction, not the quantity of change, but I think the direction of change, using the sentiments based on the text. And text is an interesting area of research. Just to, if you guys allow me to deviate for a minute, 2018, I think, has been a seminal year. If you guys have been following NLP, till 2017 or 16, word-to-vec, one-hot vectors, GLOW, these are some of the techniques. You would convert a text into embedded vectors. But in 2018, some of the solutions like transformers, ELMOFIT, ELM, BERT, has made tremendous transformation in text reading. And if you have not heard of what happened in July of 2019, just a month ago, I think Alibaba introduced a new model called Ernie 2, Ernie 1 and Ernie 2, ERNIE, which actually does even better job than BERT. BERT was supposed to be one of the fantastic models in language processing. Anyway, coming back to the original thing, detecting sentiments based on text being published, whether in the news media or any other reports being published by the companies themselves, can be predicted. And this actually model has good accuracy levels too. And there was another paper, similar one I found, I thought you guys can read. This is again a year ago. I remember, I think 10 years ago, Google's motto was mobile first. Any solution, any product the company developed was mobile enabled. But in the last 2 years, they've changed it to AI first. Every solution, every product they offer will be enabled or enhanced using AI. And this is a paper which actually talks about if you have an app that you're using to serve your customers, and you want to predict what the customers are thinking and what customers are going to be doing, this is a combined paper which actually talks about 3 distinct use cases. The activity prediction, activity analysis, and of course the engagement, how deeply people are committed, passionate about the app and then using it and enjoying it, and churn at the same time. These are all normally in traditional industry, these are distinct 3 different use cases, or 3 different models, or 3 different ensembles. There's one very interesting paper published where you can analyze the user activity and also understand how deeply involved the users are. If you're talking about apps like Uber app or a Facebook app or Instagram or those sort of things, I believe they already have a bunch of models running in the background. But if you're developing something, a new solution, which you want to find out how your customers are thinking and behaving and using and what they would be doing next, I think it would be an interesting paper. When I heard of the term uplift modeling a couple of years ago, I was really amazed. Prediction models in AI will identify those customers who are going to do what you think they're going to do. Are they going to buy a credit card? Are they going to go for a loan? Are they going to buy my aircraft tickets? Whatever. But there are certain, within those customer set, some customers need that extra push, extra nudge to take the action. Some customers don't need that extra nudge, some customers do. But here's an interesting fact. Some customers who are otherwise interested in doing, but if you give an extra nudge, they become antagonistic. They'll get really, which is an interesting fact, isn't it? I'm about to buy this car, and the car manufacturer happened to send me a discount coupon. Now I don't like the car anymore. It's an interesting phenomena in customers. If you're not familiar with that, be ready for this. Everyone has this bias. By the way, there are 175 known biases in the world. Don't be surprised. All of us have those biases. 175 biases. One of this is this, where certain type of customers who are otherwise willing to take the plunge will not take the plunge if you, the seller, makes the extra effort to connect. So you got to be careful about those people and don't do anything more there. But uplift modeling is that model which actually can tell you who are those customers who would need that extra nudge to take the action. And so that would be the next step after making the prediction. You know these customers, let's say the following 1,000 customers are the predicted by the model, or the predicted customers who would actually want to buy a car, but some of them need that extra nudge and you need to find out what those are. And that's called uplift modeling. And this paper actually talks about For example, here is the definition of uplift modeling. If buyer with treatment, so if you're giving an extra coupon or maybe an extra call from the customer service, that extra attention versus buyers who does not need or treatment or who don't want the treatment. If you look into this, people who want that extra treatment and who did not get it are the persuadables. So uplift modeling actually will tell who are those persuadable customers. So if you have that limited marketing budgets, marketing dollars to spend on, you want to not just do the prediction model, you got to go to the next step called uplift modeling, where you need to really find out who need that extra nudge so that you can spend that extra budget dollars. And there are a bunch of solutions available. I think in this paper, I think talks about what techniques work. Like even, again, here, if you look into the techniques here, these are simple classical machine learning techniques. If you're not convinced yet that it's extremely easy to develop machine learning solutions in financial services using classical methods, I'm going to talk about a couple of more ideas, but I think if you're not convinced yet, I think we should talk offline. There's another model which is more of a deep learning model identifying credit risk, especially for small businesses. If your company gives loans or leases devices or products to small customers or small businesses, how would you know the customer, the business is going to sustain for long periods and they're going to pay you back? And so you need to do a credit risk prediction. Many companies, smaller, big size companies, are engaged with SMBs. And of course, individuals also declare bankruptcy, but I think it's a small size companies declare bankruptcies. Have you heard of big size companies declaring bankruptcies? There are a good number of companies, just in Silicon Valley itself, I think, in California, declaring bankruptcies all the time. And they do come out of bankruptcy once in a while. Here is a paper. Again, the reason I guess you guys are sitting here in my session is not because Ram was a fantastic guy to introduce me, but I guess you are all interested in financial services. Here is one paper which actually uses so many different, again, classical machine learning techniques, as simple as logistic regression, to as maybe complicated as deep neural network classifies here, but also have basic random forest, decision trees, SVM techniques, which are very XGBoost. By the way, someone was asking me the other day, of all these classical machine learning techniques, what would be the best technique I should use all the time? Well, the answer is, of course, it depends, because every economist, every scientist always has to say, give an answer, start with it depends. So my answer is also it depends. But if you don't have any other technique in your mind, and if you're not sure, start with XGBoost. XGBoost does a fantastic job many, many times. And of course, you can always think about ensembles and stuff too. But if you want to go simple, you can do logistic regression or random forest, but my personal choice is XGBoost. Anyway, here is a paper which actually talks about predicting bankruptcies. I'll skip this slide. I have another 10, 12 minutes. Till now, I'm trying to say that it's very easy to develop a machine learning and AI solution for financial services, especially, as I mentioned earlier, the complexity of data, the quality of data being sometimes not accurate, and of course the compliance regulations and the new legislations that may be coming up in future. But as a data scientist, if you guys are developing a model, you got to be extremely careful about what the data is, and you got to be ready for answering questions in the context of bias, interpretability, explainability, fairness, all of these topics. If the last 2 years, if I have to predict what's going to happen in the future in AI, and that contrast that with what happened in the last 2 years, I want to make a prediction, but before I make a prediction, I will tell you a story. You guys like stories? Okay. I think in 2000, around year 2000, 1995 to 2010, I guess, there was a professor in UC Berkeley, Dr. Philip Tetley, and he, I think, moved, right now I think he's teaching in University of Chicago, I think, Booth. He did an interesting research and published a book too. And the paper and the book was so popular. And his research focus was all of these intelligent people who make predictions, especially on the televisions when they come and talk about, oh my God, company AIBC is going to go make lots of money, or company XYZ is going to go bankrupt, or Iran is going to make a deal with whatever country it is, or predicting what's going to happen in the world, how accurate these people are. Right? It's very exciting when you turn on your CNBC and then listen to what's happening, but have you ever gone back and verified whether the person's predictions came true or not? So he actually did that. He tracked 284 such intelligent people. Let's use the word intelligent. Over a period of 20 years, they made a total of 28,000 predictions. He did the analysis, used a bunch of PhD economist students, and then published findings and published a book. The summary of the findings is, the more intelligent you are or more capable you are, the less accurate your predictions are. Having said that, my prediction, what is going to happen in the next couple of years in the context of AI, especially if you have been an AI scientist, the last 2 years have been talking about how to develop AI solutions for your industry using all the techniques available and improvising on the techniques. So if you talk about RNNs and LSTMs and GRUs and stuff, which is there's improvements happening, or you talk about in deep learning models, you actually have attention models, you have transform models. There's so much of research happening, and great tips available how to optimize, regularize, and improvise on your deep learning models. But I believe if I have to predict what's going to happen in the next 2 years, I think all models, all the scientists developing all the models have to be prepared to answer the questions in the context of bias, interpretability, explainability, fairness, all of this stuff. Remember, when you develop a model, all AI models are looking into the past. They don't look into the future. We think we can make a prediction into the future, but the models are not looking into the future, they're looking into the past, because you have given the data about the past. So they can only tell you what happened in the past. They can make an analysis of what happened in the past. We think we can intelligently use these models to make a prediction in the future. Many times it works, but that's a distinction people have to remember, especially if you're productionizing models in an industry which actually impacts the lives of people, like healthcare, transportation, financial services. You've got to be ready to understand why your model is predicting ABC, whatever is the decision. So for you to equip yourself, play with the data. People say, I think, of course, 80% of the time in an AI project takes for data prep, you actually have a bunch of data visualization techniques. You can do extrapolation, and in a multidimensional space, you can find out how the data is working. And in that process, you can find out the quality of data itself. Someone told me, don't put too many bullets in a slide. And I forgot. There are lots of techniques available to make a model interpretable. Here is one simple balance you can. The more interpretable the model is, the less accurate the model. The higher accuracy the model has, the lower interpretability it has. Remember this, it's almost true. 99% of the time it's true. So if you want to make a model which is really interpretable, you actually have to go with some of the very, very simple techniques, as simple as linear regression, logistic regression, GLMs, decision trees, decision rules. These are very, very easy interpretable models, but you don't get very high accuracies. I guess sometimes maybe 80% accuracy is okay if your industry is okay with that, if it's not a life-threatening or a financial services type of thing. Maybe lower accuracy, but you're able to interpret that easily. And there are other techniques available, like model agnostic techniques, which have been published a lot, like partial dependency plots is, again, playing with the data. To identify, partial dependency plots talk about if you have a dependent variable and if you have an independent variable, among the bunch of independent variables, you can pick and choose one at a global level and then identify how much of an impact this variable has, the independent variable has on the dependent variable, the prediction, whatever you're trying to. So that's a partial dependency. So it's a dependency of the predicted value on this particular input feature, but it's a partial dependency because you're only picking 1 and 2. So you're averaging out the rest and focusing only on 1 or 2. this will help you to identify which features are more important, less important, but at the same time, it will also do a global level. Remember, this is a global level, identify which aspects are influencing the final decisions of the model, which will help you in the interpretation. And sometimes you don't want, not just on the global level, but you want to, at the local level, and that's the individual conditional expectation plots, which is actually looking at each feature and identifying each of the record which you're using for inputting training model, how these are helping you for the interpretation. There are other techniques available too. For example, example-based explanation methods, counterfactual. If A is the reason why B is happening, you can explain that using counterfactual. Because A is not there, B is not happening. And that's counterfactual, and then you can use those techniques too. I have, I think, another 7-8 minutes. I think I'll rush through this and I'll open for a couple of questions. There are a lot of examples for historical example of biases. If you haven't heard of this particular example called Compass, you should read up on this. There are a bunch of links here at the bottom of this slide. You can check this. There was a model, face recognition model used by certain courts in the United States, which was predicting the bail jumping probability of a criminal. And based on the published results of the model, a nonprofit wanted to study how unbiased this model is. And they proved that this model was completely biased, because even though the model was thinking of predicting accurately, the model was unusually biased in favor of certain race and against certain other race. And of course, the model was brought down quickly. Even though the model was doing the right thing based on the data you were given, but that's where I think as an AI scientist, you've got to be careful about what is fairness and how to train the data. You guys, when you go home today, open your Google and search for CEO in United States and click on the image section and find out what you see in that, okay? You don't need to tell me now, but you can go figure out yourself what, even today, I'm talking about, this was told to Google, I think, a couple of years ago, and they've made some changes, but if you go to Google today, or when you get a break, you should check CEO in the United States and click on the image section. Anyway, these are some of the techniques. I'm not going to explain the techniques that's available today. You should try this. Using the explainability techniques, I want to share a couple of papers. Here is one paper which is talking about credit lending. When you're trying to give credit to a customer, what factors seems to be important, or what factors was the model focusing on? And here is the using a logistic model or a line technique or a deep lift technique and integrated gradients. I won't explain the terms right now, you should go back and check, but I think if you look into it, it picks those factors and gives a score on which of these factors seems to be more important for the model. Now, it may not be true in real world, the model may be making the wrong judgment, but at least you know what the model is looking at, and then you can figure out how much of tweaking need to be done for the model, or maybe how much of human in the loop that need to be brought in for this model. This is another paper, I think, which almost talks about saliency maps. I think if you have not heard of the term, where when you're trying to do an image categorization, if you show a dog or a cat, and what portions of the image the model is looking at to make a prediction whether it's a cat or a dog, you would think the entire picture, but it's not the case. The models always look only certain portions, certain pixels. And in this paper actually goes one step further than saliency maps, talks about something called anchors, which is more of model developing certain business rules based on the training data you've given. So in other words, actually, imagine for a minute, your model is thinking like a human and telling you, the AI scientist, you know what? I think this is dog because this were the reasons why I looked at. And that's actually giving you the rules. And then the model will continue to use the same rules to predict the same class every time it makes a prediction. My last slide, and the best slide, because after this it's going to be a thank you slide. These are some of the techniques available. So if you guys have spent your personal money or your company's money to come to the conference today, or if you want to try to learn something AI, please do remember, in addition to the techniques and methodologies for developing AI solutions, you would also need to know on some of the interpretability and bias and fairness issues that's coming into the model, and you should be able to explain why the model is doing that. Thank you, guys. Thank you for your time. And if you have any questions, thank you.
We have about 4 minutes for questions. By the way, the slides will be available according to the organizers in the website.
Normally if there are no questions, there are only 2 reasons why you don't have any questions. Oh, you have a question? Go ahead.
Okay, so I'm sorry I came in late. So you were talking about model interpretability and stuff. Did you address how you correct for bias?
I did not address. I'm only highlighting that people, I think, need to be aware of that. And I mentioned a few techniques. In 35 minutes, I would not be able to explain how the bias detection works, but I think I talked about right from the imbalanced data, non-quality data, then you to the techniques where you can actually go figure out what the bias is and what the not bias is. That picture I showed about 2 different criminal for different skin color model, that's one glaring example of bias, where even though the data is right and the model is done right, but still there's a
It seems like to me always bias is an issue of sample size and balance on the different classes. Right?
Good point.
Because they're in locally linear models, there's no way to address that, just as the way you have outliers that affect this.
Yeah. If you're an AI scientist, I think if you sit with an economist, I think you'll be having a tremendous amount of disagreement, because there is a definition problem here, because we don't know what fairness is or bias is, because fairness in the context of social, cultural, financial, there's all different definitions. And the models, I think if your model is touching a cultural aspect or a financial aspect of it, you've got to be careful about what the definition is. It could be a combination of definitions too. So, yeah, we can maybe debate for the next couple of hours on what the bias is, but I think people are trying to look at bias from different contexts. That was one of the examples. There's so many other examples. For example, Amazon, I think a couple of years ago, announced same-day delivery for certain zip codes. When people actually went back and mapped those zip codes to certain races, they found the zip codes where they did not offer a same-day delivery had concentration of blacks living. And of course, there was a big PR issue, and then they figured there's so many such issues too. And even now, that's what I said. The CEO in US, when you go Google search, you'll find out what the bias is right there. Yes, sir. You had a question.
So how many iterations do you typically do in the model, and then how do you version that, or how do you go back and see like a prior version? What do you have to keep track of in order to recreate that model?
If I understand correctly, how many versions? You keep on training till the model gets overfitting, and then you go back and find out what is the right area zone. Let's say you ran for 1,000 times, 1,000 epochs, and then you found after 650 times, I think it starts overfitting or it's no much improvement. Then you pick a 500th or a 450th or 550th model. If you are looking for an ensemble, you can just combine all of those things and then find, or you can just create pickles and then keep on dumping the pickles into a data set. If that's your question, yeah, that's what normally you do in terms of identifying when to do stop testing and then using the model. But that's only one technique. Let's say you've done a deep learning model and then that's the same architecture, same parameters, and you're just looking at multiple epochs. But you should never use, my opinion, you should never give, feels like I'm giving a recommendation. My recommendation is just use an ensemble all the time, because that actually you can mitigate the risk of model making error. But one of the problems I mentioned earlier is the more ensembles you have, the lesser interpretability it is, because then you don't know which part of the answer is actually being influenced by which model, and then it's going to be more difficult. So that's the balance I think people have still not figured out. But that's my answer. Yes, sir.
You said the prediction and accuracy are inversely proportional.
Not prediction accuracy. I'm saying.
Give an example of a professor who are more intelligent.
Oh yes, yeah.
So basically, what you mean is prediction is nothing but generalization.
Uh-huh.
So accuracy is nothing but optimization. So they are inversely proportional, means it's more like a self-referential statement.
I guess so, but in this case, I think the researcher was trying to find out all of these smart people who come on the television and making prediction what's going to happen in future, and people normally blindly believe in them. Like, for example, oh my God, country A is going to bomb country B, or company B is going to tank, and people start trading on that because I think people are really looking for some experts, and the mere fact that you appear on the television may give an impression that you're an expert. So he was trying to dispel that myth that not just you're standing there on the television, you are the CEO of a company, or you've written a couple of papers or patents, automatically it makes you an expert. No, that's not true.
The reason
That
I
is-
asked is, last year, I came to know about 400 companies who are using deep learning in financial services. They shut down, closed down, maybe because of it.
There could be anything.
Yeah,
Yeah, we need-
after this.
yes, yeah, I think I'm out of time. Thank you very much,
Thank
Ram.
you so much.
Thank you guys for coming, really appreciate it. Yeah.